Hi everyone, Mr. Markwick here. The purpose of today's video is to look at matrix structure. Also, just going to talk quickly about what is a matrix, what does it look like, and then I'll go through an example from the textbook that we're currently using at the moment. So, first of all, what is a matrix? So, as it suggests here, a matrix is a rectangular array of numbers arranged in rows and columns. So essentially, it's just a bunch of numbers shown in a set of parentheses or brackets in a specific order using rows and columns. We'll talk about how they're set up in a minute. You've probably seen a matrix before already. An example of a matrix is a premiership table or a list of ingredients that will make up a recipe. Could be a shopping list. And we're going to use the numbers from that shopping list to show you what that list would look like represented in a matrix. So the shopping list of 2 loaves of bread, 1 carton of juice, 6 cartons of eggs, and 1 block of cheese would look like this. 2, 1, 6, 1 for the bread, juice, egg, and cheese. A furniture inventory from a flat, a unit, and a house shows that there are 6 chairs in the flat, 1 table in the flat, 2 beds in the flat, 9 chairs in the unit, 2 tables in the unit, 3 beds in the unit, etc. And that could be represented in this matrix here using chairs, tables, and beds across the top, flat, unit, and a house across the side here. And you can see that those numbers 6, 1, 2 come straight from this table. So I'm just putting that information from the table into a matrix. Matrices are usually drawn up not using those labels on the side either. So this one here, 2, 1, 6, 1, could be written as 2, 1, 6, 1 without the labels on the left-hand side. And the same goes for the inventory in those properties, the flat, the unit, and the house. Now, what a matrix is actually used for? There are lots and lots of different applications of matrices in the real world. In fact, I don't know all of those applications, but some of the common ones are for listing inventory. So used in business, keeping a current list of what you have in stock. If you're purchasing stock, adding it to that matrix. If you are making sales, then subtracting it from that matrix to keep a current record of what you have on hand. Matrices are used in probability a fair bit. And they're also used in graphic design or computer graphics. So each element within a matrix represents something different. It might represent whether an object is present or not at a certain location. The brightness of a color, for example, in that computer graphic. So there are lots of different applications. The examples that I'll probably be going through in my set of videos will be based around mostly inventory in terms of business and things like that. And keeping a track of stock. So, what I mentioned at the start of this video we're going to focus on is the structure of a matrix, and we're going to be talking about, in particular, the order of a matrix. So there's 3 different matrices here. This first one has 4 rows, so 1, 2, 3, 4 rows, and 1 column, 1, and we say it has an order of 4 by 1. Now we write that as 4 times 1, but we would read it as 4 by 1. It's a column matrix because it simply has 1 column. This second matrix has an order of 3 by 3. 1, 2, 3 columns and 1, 2, 3 rows. It's a square matrix. Obviously 3 by 3 makes it a square. Inside that matrix there are 9 elements. Each number is a different element. And we can identify an element by the row and column that it is in. For example, this 3 that's circled here down the bottom is the element in row 3 and column 2. And I'll talk a little bit more about using that information to put into notation or matrix notation in my next video. The matrix down the bottom here has 1 row, okay, and 4 columns. So we say it's a row matrix which has an order of 1 by 4. So an m by n matrix has m rows and n columns. And as I said, m by n specifies the order of a matrix. Okay, now order is important, especially when you want to add and subtract matrices. And again, I'll get to that in one of my next videos. So looking at when we're talking about order, first of all, the number of rows that a matrix has, and secondly, the number of columns that a matrix has, using the pronumerals m for rows and n for columns. Okay, the example I want to get to here, we're going to draw some matrices up, and I'm just going to tell you what the order of those matrices are, but you could probably work that out as we're going. So Lisa goes shopping at store A to buy 2 loaves of bread at $2.65 each, 3 litres of milk at $1.55 per litre, and 1 500-gram tub of butter at $2.35. Represent the quantities purchased in a row matrix Q and the cost in a column matrix A. So let's start with the first part, represent the quantities purchased in a row matrix Q. So we're going to do a row matrix, and we're going to label it Q. So Q equals the row matrix, so it's just going to have one row. And I've got 3 items. Basically, we're looking at bread, milk, and butter, but there were 2 loaves of bread, so 2 is the first element inside that row matrix. 3 to represent 3 litres of milk, and 1 to represent the 1 tub of butter that was purchased. Now, the order of this matrix is 1 by 3. It has 1 row and 3 columns. Okay. The second part of this question asks us to use a column matrix to show the costs. So again, I'm going to start with the A. In fact, let's use the black for that. So A equals, create my column matrix, and then I'm just putting the prices for each of those items. So for example, $2.65 was the cost of the bread. That's the first element in the matrix. $1.55 was the cost of the milk, and $2.35 was the cost of the butter. Now notice I'm not doing 2 times by $2.65 here. I'm simply putting the cost of 1 unit of bread. And I'm not doing 3 times $1.55. I'm just doing the cost for 1 unit or 1 litre of milk, because we'll get to operations of matrices where we can multiply this matrix by this matrix. Okay, and it does the work for you. Anyway, the order of this matrix, which is what I'm trying to focus on in this video, is 3 by 1. It has 3 rows, 1, 2, 3, and 1 column. Or, as we said, it's a column matrix. So the order, if I was to write that underneath, is 3 by 1. The next question gets us to draw another matrix. It says, when Lisa goes to a different supermarket, which is store B, she finds the prices for the same items, and they are $2.25 for bread, $1.50 for milk, and $2.20 for the butter. Write the cost for both stores in a single cost matrix. So now I'm going to do both stores. I'm going to do cost matrix here. I'm going to have store A and store B with the prices from store A in this column, the first column, and the prices store B in the second column here. So the prices for store A I already have in my first matrix. I'm just going to copy them across. So it's $2.65 is my first element in this matrix, $1.55 for the milk, and $2.35 for the. And then for store B, I had different prices of $2.25 for the bread, $1.50 for the milk, and $2.20 for the butter. Okay, and the order of this matrix, as you probably can already deduct now, is 1, 2, 3 by 2. It has 3 rows and 2 columns. And again, you can label it here if you want, but not necessarily needed. When we're doing matrices using our graphics calculator, you won't actually be able to label the rows and the columns like that anyway. Okay, so that's it. Basic introduction to what matrices are, what they look like, the structure in terms of matrix order or matrices order. Thanks for watching, guys.